Hello and welcome to Chemical Interactions with Mrs. Castanera. We're now on to lesson 3, which is all about how simple molecules interact. So, lesson 3. Today's lesson is about molecular forces. Our keywords for the day are covalent bond, share, molecule, intermolecular in groups. Let's start again. Okay, let's go through these questions. Question 1, name the two main groups of molecules. Well, those would be elements and compounds. Make sure you use a pen in a different colour to correct or tick your work. Question 2, molecules are made of more than one atom bonded together. So the answer was more than. Question 3, name the force between simple molecules. Okay, so between the molecules we have intermolecular forces or intermolecular force. Question 4, name two ways that atoms can bond. They can bond through ionic and covalent bonding. So far we've mainly talked about covalent bonding. There are other alternative acceptable answers to this, including metallic bonding. We're not going to worry too much about that. These are the two answers I wanted from you, which was ionic and covalent bonding. Those are the ones I would expect. An incorrect answer for this question would be intermolecular bonding. That's not a type of bonding. That's something different. That's a force. It's not strong enough to be called a bond. Question 5, name the two states of matter for simple molecules at room temperature. Well, we find them usually as a liquid or a gas. Name the bond between non-metals. So the bonds between non-metals are covalent bonds. So today's lesson we're going to be describing how simple molecules interact. So what are simple molecules? Well, simple molecules usually exist as liquids or gases at room temperature, which is something we should already know. And that's because the bonds between the molecules are weak. Okay, so the covalent bonds between the individual atoms in the molecule is strong, but the bonds between the molecules are weak. This bond, or these bonds, are called intermolecular forces. So the molecules in a gas or a liquid can move, we call that flow, and they can take the shape of the space that they are in, and that's because of these weak intermolecular forces. So the molecules in a gas or liquid can flow, they can take the shape of the container, and that's because of the weak intermolecular forces. So the weak intermolecular forces. So the reason they can flow is because these intermolecular forces are so weak, okay, they allow molecules to slide past each other. They're not strong enough to keep molecules in one position. They're so weak they allow the molecules to slide past each other. I'm going to write that down. If you could do the same, please. So the intermolecular forces are so weak the intermolecular forces are so weak that the molecules can easily slide past each other. So they slide in liquids, or they simply move past each other in gases. I'm going to put in liquids in brackets for that so we are clear about what phase we're talking about. So the intermolecular forces are so weak that the molecules can easily slide past each other. So we're going to move on to learning activity 1, which is all about labelling the bonds and forces. So using the diagram on the next page, we're going to draw dashed lines. Very important that we draw dashed lines. So only one of these intermolecular forces has been drawn for each of the 3 diagrams. Your task is to go ahead and draw more of these intermolecular forces on each of the 3 diagrams, and to label the covalent bond and the intermolecular. Okay, so here you can see my attempt at this activity. So I've drawn some intermolecular forces between various parts of each molecule and repeated this for each of them. It doesn't really matter whether your dotted lines go between this O or this O and this O or this O, as long as there is at least one set of intermolecular forces between each molecule, so they are all joined to at least one other molecule with an intermolecular force. If you have a few more or you have a few less, that's not a problem. What also is important is that you've labelled your intermolecular forces. So I've labelled mine here. At this point, I'd like to turn to the student notes page so we can discuss something about the size of covalent molecules and the number and strength of the intermolecular forces. On it, I would like you to draw a short title that says Intermolecular Forces and Molecule Size. So this is the title for this section. Now, what we're going to do is we're going to draw, very similar to what we've just drawn, some hydrogen atoms. So if you've got a ruler, you can underline that. I hope you did a better job than I did there. So we're going to draw some hydrogen molecules covalently bonded together. Very similar to what we just did. Then we're going to attempt to draw, we'll do a couple more of those. Okay, then on the other side of the page, we're going to need a bit more space for this one, so we'll make the other side of the page a bit bigger. On the other side of the page, we're going to attempt to draw something a little bit larger, a much larger molecule. So for this, because we've only got limited space, we are going to draw something known as a hydrocarbon, and it will have a carbon in the centre. And then 4 hydrogens surrounding it. And this is methane. We're going to try and draw 5 or 6 of these, if we can. Tricky to fit on the page, we'll draw them quite small. Yes, it will probably take you a little while to do this. Hopefully you've drawn something similar to this. Now we're going to draw the intermolecular forces between them. So here we have hydrogen. Let's just draw some forces. Here are some intermolecular forces. It doesn't matter exactly if it's not perfect. You just need to sort of draw a couple of forces, preferably something joined into each individual molecule. So there we go, there's some hydrogen forces. Sorry. So here we've drawn some intermolecular forces between hydrogen molecules. There could be quite a few, or there could be not very many, but either way you can see roughly the number of intermolecular forces there. And this is hydrogen. Now over here we have methane, CH4, and hydrogen is H2. And methane has got a lot more, well, it's got 3 extra atoms in its molecules, in each of these molecules. So we're going to draw some intermolecular forces.
And straight away, you'll notice there are a lot more atoms for you to bond together. There's a lot more places these bonds can join up. There's just generally a lot more options.
And you'll quickly see that when you sort of draw the similar, there's going to be a lot more in the way of intermolecular forces here. I'll just continue doing this for a minute. So as you can see, this has got quite messy, and that's because, well, there's just so many options. So as you can see, this diagram here with methane has got a lot messier than the diagram with hydrogen, because there are just simply so many opportunities for intermolecular forces to occur because there are more atoms available. So each atom has more opportunities to make connections between other parts of other molecules, other atoms and other molecules. So instead of making 1, maybe 2 connections per atom, each atom could have 4, 5 or 6 connections. It could have many more than this. And as you increase the size of your molecule, more and more connections will be made. More and more of these intermolecular forces occur. So hydrogen is a smaller, simpler molecule. And it has fewer and weaker intermolecular forces. And that's because each individual molecule is attached to the other neighbouring molecules with fewer of these intermolecular forces. And then methane, each of these molecules is attached to its neighbouring molecules with many more of these forces. And so that creates a stronger overall intermolecular force. So I'm going to write some notes here. These are larger, more complex molecules. And they have more and stronger intermolecular forces. Now, what we have seen here is simply 2 very simple molecules. And you can see the difference between one slightly less simple molecule to one very simple molecule. Now, I want you to think about this molecule, okay? And it's a molecule we've looked. So the dashed line shows that the force is weaker than the bonds. That's these intermolecular forces. And the bonds, which are solid lines, are much stronger. So as these molecules move around in their gas or their liquid, the intermolecular forces will change. And the reason for this is because these individual molecules are moving, okay? And their position in relation to each other changes. So as some molecules drift further away from each other, these forces will be broken, they will be overcome, they'll be too far apart for there to be a force. So as they get further away from each other, the forces are broken and change, whereas new forces, new intermolecular forces, are remade. So these little forces between them, which are like bonds but not quite the same, these forces are constantly broken and remade as they move away from each other and closer to new molecules. So these intermolecular forces have just enough strength to keep the molecules close to each other. and only just. So they have just enough strength to keep the molecules close to each other. Now, if the molecules are heated up, they will move faster because they have more kinetic energy. Kinetic energy is moving energy. I'm going to write that down. So, moving energy. So, anything that is moving has kinetic energy. Okay, so this means that the intermolecular forces would not be strong enough to keep the molecules together. Okay, so when we heat up molecules, they move faster, they have more kinetic energy, and then the intermolecular forces would not be strong enough to keep them together. Okay, that means these individual molecules are able to move apart because they have enough energy to overcome the strength of the intermolecular force. So the molecules have been given enough energy to overcome the strength of the intermolecular forces. And the effect of this increase in energy is that the molecules end up further apart. So you give molecules energy, they end up further apart. And you should know already, because we've already learnt about solids, liquids and gases, that solids are very close together. You give something that is solid heat energy and it will turn into a liquid. Okay, and if you give a liquid heat energy, it will turn into a gas eventually. So, increasing the energy means that these molecules can overcome the intermolecular forces that are attaching them tightly to each other, and it'll become a liquid where there are less intermolecular forces between the molecules because they've got enough energy, enough kinetic energy to overcome the strength of the intermolecular forces. Not all of them, just some of them. And then as it changes from a liquid into a gas, because it's got more kinetic energy, even more of these intermolecular forces will be broken. It will overcome the strength of these intermolecular forces, and they'll be free to just move around with far turn into a gas. If it happens in a gas, well then the molecules just end up moving faster and further apart. So, brief review here on what these phases are called. I would like you to try and do this yourself. So, a solid that turns into a liquid, I'd like you to label this process. A liquid that turns into a gas, I'd like you to label this process. A gas that turns into a liquid, I'd like you to label that process. And a liquid that turns into solid, I'd like you to label that process. So pause the video whilst you do this, please. Okay, so let's go through these. So a solid turning into a liquid, that is melting. If you got it right, tick it. If you didn't, use another coloured pen to correct your answer. A liquid turning into a gas is evaporating. Again, tick it if you got it correct, or correct it if you got it wrong. A gas turning into a liquid is condensing, sometimes also called condensation. And a liquid turning into a solid is freezing. Okay, so I'd like you to give yourself a mark out of 4, please, for that. And now we're going to have a little self-quiz, where basically you are going to review the knowledge you've learned over the last 3 lessons. Book. What I strongly recommend is you get someone at home to quiz you, and one of the best ways of doing this is by using your organiser, your knowledge organiser. And so far we have done all the way up to number 15. Okay, question 1. Name the two states we usually find simple molecules in. We usually find simple molecules in the liquid or gas state. Make sure you use a pen in a different colour to mark or correct your answers. Question 2. State the number of electrons shared in a covalent bond. So 2 electrons are shared in a covalent bond. Question 3. Name the force between molecules. That would be intermolecular force. Question 4. Name the bond between non-metal atoms. So we should know that non-metal atoms have a covalent bond. So make sure you tick those or correct them. And we're going to move on to the next page. Question 5. Describe the strength of this bond in question 4. So the strength of a covalent bond is that it is very strong. How does heating affect the covalent forces, the intermolecular forces in question 3? Okay, so heating them reduces their strength or weakens them. Question 7. Name the energy store given to molecules when they are heated. So they are given kinetic energy. Name the 3 states of matter. So that's solid, liquid and gas. I know that most of you also know about plasma if you've put that well done, but you do need to have solid, liquid and gas as the 3 answers to get this correct. If you've missed one of those out, you cannot have the answer. Yes, plasma is That's because the same reason that gases turn into liquids when the substance is cooled. It's just the same process. So the particles have less kinetic energy and slow down. Intermolecular forces increase in strength, forcing the molecules close together, turning it into a solid. It's literally the same answer with the word solid at the end.